In this video, I'm going to demonstrate how to compare two rasters. Now we have the reclass 2024 and reclass 2004. And as you can see that I have kind of changed the color scheme and matched it up, right? And you already know what these values are from the table. So you can look up your Canvas page again for the table names or for the class names. Now, if you kind of toggle this layer, you will understand, you can understand where the urban area grew, but you cannot really quantify when in this scenario when you're just toggling. And so this next step we are going to do is quantify where this change has happened, how much this change has happened, and from which land use class that change happened, right? So to and from. So we're going to use the raster calculator, which does raster math. There are multiple math tools here, but I use the raster calculator because it's kind of easy to use rather than using individual tools. So you should go to the spatial analyst tool, and here you have the map algebra toolbox, and there is just one tool called raster calculator. And here I'm going to add these two layers. Why add? Because if I add the two layers, then you have to be very clear about the arithmetic here. Pixel values that are 10 adds up with pixel values that are 1. You'll get the value of 11. You have two matrices, right? So you add two matrices, you get like values like 11, starting from 11, 12, and your highest value will be 55, right? So it's cell-wise addition, right? So let's do it first, then we can discuss about it. So I will go to these raster layers. I'll double click on raster LULC 2024. In the operator symbol, I'll double click on plus symbol, and then back to the raster panel, I'll double click on 2004. And in here, I will just rename it as change LULC 2004 to 2024 and click run. Once this is done, you can see a raster layer like this would be added. And as I mentioned, the pixel values will range from 11 to 55. That means if you add 10 plus 1, 10 plus 2, so on and so forth, and then it goes on till 55. So one thing first, it's easy to identify is that whichever class was 1 in 2004, that's water, and 10 in 2024, so these are unchanged classes, right? So like 11 is an unchanged class, and let's color them as gray. So this is already gray. 20 plus 2, so whichever was 20, which is urban, and remained as urban, right? So that's a big chunk. I will color them as gray. You see the whole area that is unchanged urban, right? From 2004 to 2024. And then 33 was unchanged bare land, right? Not too much difference. And 44, 55. So you can see majority of the areas, these are unchanged areas. Now, the rest of the area, as you can see, are the changed lands, right? So if you zoom in, so you can see a lot of these pixels which are in different colors. So let's give a color scheme. And the color scheme being that any class that became 1, so that became 1 as in that became a water body, which is kind of interesting. Any class that became water body in 2024, let's make that maybe blue. 20, so any class that became urban, and I think this is going to be the huge chunk that became urban. Let's change that to red. Okay, let's change that to red. And as you can see, the majority is from cropland. So here we can already identify that the majority of the land change that happened around the Chicago area in the Chicago suburbs are actually cropland being converted into urban area. So that's your 25. That means it was 20 in 2024, but originally it was class 5 in 2004. And then you have the barren land. Let's do that some sort of yellowish or dark yellowish color. And the rest I changed the cropland that converted into cropland as light yellowish, and the 40s are the one that changed into green areas or forested area as green. So mostly we can see that again a huge prevalence of converting into the urban layer, right? So right click and open the attribute table, and that's where you will see the count, right? So what I would suggest is rather than thinking and keeping this in mind, add a class name, and that would be your text, and save it, and kind of add these explanation for your reference, so that when you are labeling, you have to create a map with that. You can use this class name as a label for the legend rather than this values 1 11 12, because 11 12 55 doesn't mean anything to a user or a viewer who is just viewing this map, right? You and I who are creating this map can know, but for a general audience, this is not a good way of labeling a map. So for here, I would say unchanged water body. I will do the unchanged first, unchanged urban, and so on and so forth. Every time you write something, make sure you save it so that you don't lose suddenly if something goes wrong, and you fill out this table. Once this is done, we are going to also calculate the amount, and specifically first we need to add a column. So let's name it as area, and we're going to make it as float, and let's do the numeric as 2 places after the decimal. Click OK and save. And now that we have the area, let's look at the cell size here, and that's 30 by 30. And now we are going to calculate the area as you have done previously in the lab where you're working with the raster data set.